Good evening, students. Uh, Last class I have left. I haven't cleared some of the concepts. So here I'll revise some of the topics which will be required in this uh, your lecture. Let P be the centric forces, and let there be a transverse cut, and Q be the Q be the P be the axial force and Q be the transverse force, whichever acting perpendicular to the means your plane is transverse loading. So if there is, that is the shear force means free body diagram, then here it's P, here it's Q. So to balance this, we have one normal force which is N, and which is equal to P for transverse cut. If it is an inclined cut, there will be some um, theta factor will come into effect, which I have shown to you. And if it is a B, then B is equal to Q. And also the stress distribution will not be uniform. We have assumed the stress distribution to be uniform. In fact, the stress distribution will be maximum along the axis, but it will be minimum along the edges, like this. And sigma is equal to shear stress, which is force acting per unit cross sectional area. Cross sectional area x I have shown. So sigma is equal to P by A naught. A naught is the original cross section area, and tau is equal to V by Q by A naught. Here V is equal to Q, and uh, your N is equal to P. Now again, let it be x-axis, let it be y-axis, 2D planar stress. It is sigma x. If it is if it is away tension, then we take as positive for normal stress. Similarly, tension is away, and compression is towards the means your plane. Yes, and positive shear stress, it is x y positive axis, that's why it's positive, and say y x along the x axis and perpendicular to the y plane. So along the x plane, along the x direction, and perpendicular to the y plane. So it is perpendicular to y plane and along the x direction. This is the shear stress. So shear stress, since x is positive in this direction, so these two are positive shear stress. And to balance this, we have shear stress in the opposite direction, which are same in magnitude but opposite in direction. Now again, if we consider if we consider plane stress, simply plane stress, plane shear stress means pure shear stress condition. If we consider pure shear stress condition, then 1 second. So it is it is basically to pop don't know how. Yes, xy, this is yx and this is xy. uh, this is xy and this is yx. So if we take the moment for equilibrium, these two will do anti-clockwise moment and these two will do clockwise moment. And for equilibrium, for equilibrium, tau yx into s square into the perpendicular distance tau xy s square, if we consider a unit square into a, this implies for equilibrium these two pair of stresses must be equal. Now we start new topic, 2D or plane stress. Sign convention as always. Sign convention. Normal stress, for normal stress, tension is positive and compression is negative. And for shear stress is positive if it is in the positive direction of coordinate axis. Coordinate axis. And angle, anti-clockwise angle positive. Measured from positive x axis as reference. Now, so what does it mean actually? Basically, uh, we have sigma x tension, sigma y, similarly sigma x tension, sigma y, these are positive. This is positive shear stress because it's in the positive y direction. Similarly, it's positive yeah, your shear stress because it's in the positive x direction. Similarly, this and your these are negative actually. Now this angle is theta and it is measured along anticlockwise direction, so this inclined angle is positive. So similarly, if we draw the free body diagram of this portion only, 3D diagram of this portion only, we have we have, this is sigma x, this is sigma y, this is tau yx or tau xy, and this is theta. So if you clearly see, that will be theta, because this is perpendicular to this, is perpendicular to this, and this is perpendicular to this. So clearly this will be theta. So this angle which is measured positive, means anti-clockwise, angle measured from positive x axis, uh, as reference. So it will be sigma n, normal to the any arbitrary normal, any arbitrary your normal stress, and this is nt, your along t coordinate axis. So it is x axis, and this is y axis, this is normal, and this is normal, means perpendicular to the normal axis, tangential axis. So if this is theta like this, then this angle will also be theta, because these two makes 90 degree and this two makes 90 degree. Now in general, sigma x, sigma y, and tau xy or tau yx, which are same, can be found from loading condition. Loading condition, we have to find sigma n and tau nt, means normal stress and shear stress on the inclined plane. Now this is nothing but let this be the area of the inclined plane, and this is theta. Clearly we have seen here it is theta, so this is theta. So this your this area will nothing but dA cos theta, and this area will nothing but dA sin theta. If we draw this in 2D, if this is dA, here it is per unit length, then it will be dA cos theta, and this will be dA sin theta. Now convert stresses to forces, then what it will be? If it is theta, sigma n dA, just dA into, and tau n t dA, it is sigma y dA sin theta, and it is sigma x dA cos theta, and tau xy dA cos theta, and this is tau yx dA sin theta. Since it means, just multiply the stresses with its respective area of cross section. Now what do we have? What are the forces we have? The forces are sigma n dA, tau nt dA, sigma x dA cos theta, sigma xy dA cos theta, sigma yx dA sin theta, and sigma y dA sin theta. These are the forces. Now applying equilibrium. Applying equilibrium. What it will be? This, it is 90 degree minus theta. So summation of resultant of all the forces along normal direction and taking this as positive. So what is equal to 0? What it will give? Sigma n dA minus minus will be because your sigma x is in this direction. If you see sigma x, it is in this direction. So if we wants to means show its direction, it will be in this direction. So clearly it is in negative direction. So sigma x dA cos theta and multiply into cos theta to get its component in along n. Now minus sigma y. What is sigma y? It is sigma y ds sine theta, and it is in this direction. Again minus will come, minus sign will come, and it is cos 90 degree minus theta to get its component along normal direction. So cos 90 degree minus theta is sine theta. Whatever is here in this direction, it will be cos. Whatever is in the along this axis to means get component along normal direction, it will be sine. So similarly, your tau sigma xy dA cos theta, my xy dA cos theta is, my xy dA cos theta is this only y. So y, in case of y, it will come like that, and sigma yx, this one, uh, this is yx ds sine theta. It is nothing but in this direction like sigma x, so it will come cos theta is equal to 0. But star sigma xy is equal to sigma yx, as we have already know. So sigma n, since area cannot be is equal to 0, uh, so this term will be is equal to means if you take a common, a and within that bracket means right, means I am writing this step again, dA common, if you minus sigma x cos square theta sigma y sin square theta minus twice tau xy sin theta cos theta is equal to 0. So I means if we get multiplication like that, either this term is 0 or this term is 0. Since dA cannot be 0, so this is equal to 0. Sigma n minus sigma x cos square theta, area can't be 0 na, because we have considered an area of an element. There cos theta is equal to 0 since dA can't be equal to 0. So sigma n is equal to sigma x cos square theta plus sigma y sin square theta plus twice tau xy sin theta cos theta. Now cos square theta is equal to 1 plus cos twice theta divided by 2. Sin square theta is equal to 1 minus cos twice theta divided by 2, or 2 sin theta cos theta is equal to sin twice theta. It's from trigonometry only. So this implies sigma n is equal to sigma x 1 plus cos 2 theta sigma y 1 minus cos 2 theta or tau xy sin twice theta. So it will give nothing but sigma n is equal to sigma x plus sigma y divided by 2 plus sigma x minus sigma y divided by 2 cos twice theta plus tau xy sin twice theta. It's a Very important derivation. Normal. Normal stress on an inclined plane. Now we have to calculate also shear stress. But before that, we have to again see, uh, like, we'll see whether whatever we have derived, is it means uh, okay with our intuition also. So let's see. If you see, theta is equal to 90 degree, if theta is equal to 90 degree, then n is equal to whatever sigma n is, will be equal to, so whatever sigma n comes, it will be equal to sigma y. So let's check whether it comes or not. When theta, example, actually when theta is equal to 90 degree, then clearly sigma n must be equal to sigma y. We have to we'll see whether it comes or not. It's sigma x plus sigma y divided by 2 plus sigma x minus sigma y divided by 2 cos 180 degree, 2 into 90 degree, so tau xy sine 180 degree. Now sine theta positive, positive, negative, negative, cos theta positive, negative, negative, positive. It's in trigonometry, you must know. If sine is this quadrant, in this quadrant, theta is in this quadrant, value of sine will be positive, this will be positive, here it will be negative, here it will be negative. Cos in this quadrant is positive, cos in this quadrant is your cos in this quadrant is negative, cos in this quadrant is negative, but in this quadrant is positive, means cos greater than 270 degree gives positive. Let's see, your cos 180 degree is nothing but cos of 180 degree minus 0 degree. So 180 degree minus 0 degree means in this quadrant, so cos will be negative. So cos in this quadrant is always negative, so minus uh, cos 0 degree, and minus cos 0 degree is minus 1, minus cos 0 degree. Similarly, sine 180 degree is nothing but sine 180 degree minus 0 degree. So 180 degree minus 0 degree means in this quadrant, the sine in this quadrant is always your positive, means sine. So here it will be positive sine, sine 0 degree, and sine 0 degree is 0. So this is 0, and this is sigma x plus sigma y divided by 2 plus sigma x minus sigma y divided by 2 minus 1. So clearly sigma x plus sigma y minus sigma x minus plus sigma y, so twice sigma y, 2, it is sigma y. Clear? So we have got, we have means find that thing. Now I'll teach you. Similarly, you don't have to prove actually. Similarly, if we take the summation of f of t, we have x, y, n, and this is t. If we take all the forces, summation of f of t along this direction positive, then we will get sigma nt, means tau nt shear stress along the inclined plane, sigma x minus sigma y by 2, angle is changing, and so this is another stress, shear stress acting on the plane. So you have got n is sigma x plus sigma y divided by 2, your again sigma x minus sigma y divided by 2 cos twice theta, and plus tau xy sine twice theta, and tau nt is minus, here it is plus, here it is minus, same thing, sigma x minus sigma f. In order to remember, always means trigonometry changes, plus this plus comes and trigonometry changes to cosine, it is twice theta. So this is the important reductions or formula, value of normal stress and shear stress on an inclined plane whenever it is rotated by an angle theta with reference to coordinate x-axis, positive direction of x-axis. Now for all civil engineering, structural design, structural design, maximum value of sigma n and tau and t need to be calculated or evaluated. Now theta p, we have to find out principal stress, means what is maximum normal stress, principal planes. I'll give the definition, it's a very important. Principal planes, so where max maximum oblique minimum normal stress occur and shear stress is zero, are defined as principal stresses. Principal stresses. Now, to find maximum principal stresses, what we do in calculus, we have to means differentiate this time with respect to theta and is equal to 0. For maximum sigma, for maximum sigma n, derivative of sigma n with respect to theta is equal to 0. What it is, this is constant, this is 0, this is sigma x minus sigma y divided by 2, and cos twice theta is minus sine twice theta, and for 2 theta 1 2 came, and again tau xy constant, sine twice theta is cos twice theta, and for 2 theta 2 comes is equal to 0. It is nothing but minus sigma x minus sigma y given of this sine twice theta and plus tau xy 2, taking 2 common and is equal to, means here 0, so this term is 0, cos twice theta is equal to, clearly tau nt is equal to 0, means shear stress vanishes, that is shear stress is 0 at principal planes. Now tan twice theta, from this only, tan twice theta is nothing but taking this side common, we will get to tau xy sigma x minus sigma y, or tau xy or sigma x minus sigma y divided by 2. This is tan twice theta p, when theta is equal to principal plane. This implies tan twice theta p is sorry tan twice theta p is nothing but xy sigma x sigma y. Now we tan twice theta p into sigma 2 xy sigma x minus sigma y. Now again here this is sigma y, sigma x, sigma, or this is sigma xy. Yeah, above this should be in this direction. Here xy minus. Now clearly from 10 you can see that the value differentiate. You can see the tangent function repeats every 180 degree. Every 180 degree you can see the tangent function repeats 90 to 70, means the tangent function repeats every 180 degree. So for a given set of values of sigma x minus sigma x, sigma y and tau xy, the value of twice theta p differ by 180 degree. That is the principal planes theta p are 90 degree apart. Since twice theta p 180 degree apart, so theta p is definitely divided by 2 90 degree apart. 90 degree means mutually perpendicular planes. That is, if it is theta p, if along x-axis it rotate and sigma n becomes sigma 1 because of one maximum principal stress, and for me another principal stress uh, which is minimum sigma 2. uh, so these two planes should be mutually perpendicular, sigma 1 and sigma 2. Again we can see for tan theta function, this is positive, this is negative, this is positive, and this is negative. Clearly after 180 degree the things repeated and signs becomes same. Now you can see tan twice theta p is equal to 2 sigma xy sigma x minus sigma y is nothing but this sigma x minus sigma y divided by 2. If it is twice theta p, then clearly this is sigma x turned permanently, and this is sigma x minus sigma y divided by 2. So the radius should be, or hypotenuse should be, this square plus tau xy square. And after this 180 degree plus twice theta p, we will get another uh, your principal plane, where things will be uh, where thing will be same, means I will explain what the thing, where thing will have, because here it will, you will get tau xy negative and sigma xy minus sigma y divided by 2 also negative, because this negative, so tan twice theta p will be positive in this quadrant, like so. If we consider sigma x minus sigma y divided by 2 and sigma xy are of same sign, when they are of same sign, then tan twice theta p becomes positive. So twice theta p is between 0 degree and 90 degree, or 180 degree and 270 degree. That is, there are two values of theta p. One is between 0 degree and 45 degree, and the other is 90 degree greater, when rotation is taken clockwise. Similarly, one is between 90 degree and 180 degree, and the other is between 270 degree and 360 degree, when considered again clockwise, your sorry, anti-clockwise rotation, clockwise rotation, then twice theta p r of is negative, and sigma x minus sigma y divided by 2, and your tau xy are of different sign. If those two are different sign, then your means tan twice theta p will be in this your coordinate twice theta p. Now, so tan twice theta p is equal to plus minus sigma xy, sigma xo minus sigma y, from here we clearly have if it is twice theta p, it is tau xy, if it is sigma x minus sigma y divided by 2, and this is sigma x minus sigma y by 2 whole square plus tau xy whole square, then cos twice theta p is again plus minus sigma x curly black here hypo, this is this sigma x minus sigma y divided by 2 whole square plus tau xy square, and sin twice theta p equal to plus minus some people perpendicular have hypotenuse. So now now we have sigma n is nothing but this. No, here. So clearly putting this value here in this, what you will get when we will put this value, sigma 1 and sigma 2 will be in uh, uh, principal stresses, because these sine twice theta p and cos twice theta p are means cosine and cosine value corresponding to principal stresses. Now what it will have, sigma x plus sigma y divided by 2, it is plus sigma x minus sigma y divided by 2, and it will be plus minus sigma x minus sigma y divided by 2 root over sigma x minus sigma y divided by 2 whole square plus tau xy square, again plus tau xy, and sine value is plus minus tau xy root over sigma x minus sigma y divided by 2 whole square plus tau y xy square. Do it now. What will get? What will get? Sigma 1 2 is equal to sigma x plus sigma y divided by 2. If we take this thing plus minus common, and this your denominator, what it will have, sigma x minus sigma y divided by 2 whole square plus tau xy square, and these two thing got multiplied, sigma x minus sigma y divided by 2 whole square plus tau xy square. So if we cut this, it will cut the squares. What you will get, nothing but sigma x plus sigma y divided by 2 plus minus root over sigma x minus sigma y square plus tau xy square 2. So this is a very important derivation. If sigma 1 greater than sigma 2, if you consider sigma 1 as measure principal stress and this as minor principal stress, then sigma 1 it will be this plus sign sigma x minus sigma y divided by 2 whole square plus tau xy square, and sigma 2 is equal to sigma 1 plus sigma 2 divided by 2 minus sigma x plus sigma 2 divided by 2 whole square plus tau xy square. This is a very important derivation. You will get the value of the principal stresses. Again, you see, again you can see your, again you can see uh, your, again you can see your, if we plus sigma 1 plus sigma 2, we will nothing get. It is sigma x, sigma y, sigma x, sigma y, sorry. If we plus sigma 1 plus sigma 2, it will come out to be sigma x plus sigma y. So this is called stress invariant. That is sum of normal stress on any. If we do plus, these two will cancel out, then uh, uh, these two, this will become twice of sigma x plus sigma y divided by 2, 2 to cancel out, then sigma x plus sigma y on any two perpendicular plane is constant invariant. Now for maximum shear stress, maximum shear stress, sigma nt max, tau nt max, your, we have tau nt, what is the formula? Just like that, we will write down its sine twice theta plus tau xy cos twice theta. Now differentiating theta is equal to 0, you will get minus sigma 2 divided by 2 sine, you will get twice theta 2. So derivative, because cos twice theta, it will be minus sine twice theta, so it will give cos sine twice theta, and this will give this is equal to 0. Then we will get tan twice theta, or tan twice theta s is nothing, will be nothing but sigma x minus sigma y twice this, or you can just write sigma x minus sigma y divided by 2 tau xy, and this is maximum shear stress plane. You can see twice theta p, it is nothing but, it was, if you remember this, you can remember that also, and twice theta s, it is just opposite, reciprocal, negative reciprocal, that is tan twice theta p is the negative reciprocal of tan twice theta s. Example, like if tan 45 degree we know 1, and tan minus 45 degree, it is minus 45 degree means tan 45 degree, and tan minus 45 degree, if we move in this direction, so it comes minus 1, negative reciprocal na. So angle between them is 90 degree. That so whenever it is a negative reciprocal, so twice theta p theta s are 90 degree apart. That is theta p and theta s are 45 degree apart. This is another important statement. So maximum shear stress maximum shear stress planes occur at 45 degree apart from principal planes. Now we'll move here directly since we have drawn a diagram here. If we x minus sigma y divided by 2 whole square plus tau xy square, if it is, we know 10 twice your what is theta s, it is nothing but you will see 10 twice theta s is sigma x minus sigma y. So it is sigma x minus sigma y divided by 2 or tau xy. So if it is 10 twice theta s, it is x sigma y divided by 2 minus or tau xy. Then clearly your sine twice theta will be nothing but minus of minus of sigma x minus sigma y divided by 2. Some people have or sigma x minus sigma y divided by 2 whole square plus tau xy square, and cos twice theta is equal to curly black xy divided by sigma x minus sigma y divided by 2 whole square plus tau xy square. And now if we put in your tau nt formula, like what we have, sigma x sigma y cos twice theta, sine twice theta, and this is tau xy cos twice theta. If we put those two values, we will get sigma nt is comes out to be your this is minus minus becomes positive. uh, Let me write down the thing. It is minus sigma x minus sigma y divided by 2, and it is sigma x minus sigma y whole square plus tau xy square. Tau xy or cos theta is nothing but tau xy, or this is sigma x minus sigma y 2 whole square plus tau xy square. So this becomes positive, and sigma x minus sigma y by 2 whole square, and if we take the thing else LCM, uh, LCM tau xy square denominator, so tau xy square, so you will get nothing but sigma x minus sigma y tau xy square. This implies sigma nt maximum, or simply sigma max, is equal to sigma x minus sigma y by 2 whole square plus tau xy square. So this is another important derivation. Now if you recall, if you recall if you recall principal stresses, what you have, sigma 1 is equal to sigma x plus sigma y divided by 2 plus sigma x minus sigma y divided by 2 whole square plus tau xy square, and sigma 2 is equal to sigma 1 plus sigma 2 divided by 2 minus sigma x minus sigma y divided by 2 whole square plus tau xy square. If sigma 1 minus sigma 2, then you will get twice of root over sigma x minus sigma y divided by 2 whole square plus tau xy square. This implies sigma x minus sigma y divided by 2 whole square plus tau xy square, which is nothing but tau max, as we have already calculated, is equal to sigma 1 minus sigma 2 divided by 2. That is maximum shear stress tau max is equal to half of sigma 1 minus sigma 2. So now uh, summary is equal to sigma x plus sigma y divided by 2 plus sigma x minus sigma y divided by 2 cos twice theta plus tau xy sin twice theta, and sigma t is equal to tau and t is equal to minus of sigma x minus sigma y divided by 2. It is sin twice theta and tau xy cos twice theta, and tan twice theta p is twice tau xy sigma x minus sigma y, and tan twice theta s is nothing but the negative of reciprocal, so it will be sigma x minus sigma y, negative of this reciprocal, and sigma 1 and sigma 2 is nothing but sigma x plus sigma y divided by 2 plus for sigma 1 and sigma 2 negative sigma x minus sigma y divided by 2 whole square plus tau xy square, and sigma 1 plus sigma 2 is equal to sigma x plus sigma y, and tau xy is nothing but sigma 1 minus sigma 2 divided by 2, or sigma tau x divided by tau xy square. These are the all the derivations, and these are the summary which we have done today. Whenever we have to find the stresses on an inclined plane, and you see sigma x is along this direction, y is along this direction. Whenever we rotate an angle theta in anti-clockwise direction, we have to find the normal stresses and the tangential or shear stresses along the tangential direction. Your sigma x is this, sigma normal sigma y positive. This sign convention you have to follow. If sign convention sigma x is taken in this direction, then it will be sigma x, value of sigma x whatever, if it is 520, then you have to take minus 520 and put in this value. If value of shear stress is given in this direction, so 260, so you have to tau xy is equal to minus 260, because this sign convention we have taken positive. Based on these phases whatever, we have to put the value of means algebraically you have to put the value of sigma x, sigma y and tau xy. So it is tau yx, and you have to rotate it by an angle theta, and it will be anti-clockwise rotation. So that's all of today's class.